At the Newport News shipyard in Virginia, there's a warship that could represent both America's greatest technological achievement and its most expensive failure. The USS John F. Kennedy is 1,092 feet of cutting-edge engineering, longer than 3 football fields, powered by 2 nuclear reactors and designed to carry more firepower than most countries' entire air forces. It's structurally complete, it's been launched, and it cost $13 billion to build. But here's the problem. It doesn't work. This ship was supposed to join the fleet in 2018, then 2022, then 2024. Now the Navy says March 2027. For nearly a decade, the most advanced warship ever built has been stuck at the dock. Not because they ran out of money, not because they ran out of steel, but because of something absurdly simple. Elevators. How does a $13 billion aircraft carrier get delayed by elevators? Let's find out. Now, before we look at the broken tech, we have to understand why this delay is terrifying the Pentagon. You see, an aircraft carrier isn't just a boat. It's 4.5 acres of sovereign American territory that can move anywhere in the ocean. It doesn't need permission from allies to host jets. It just shows up. Federal law actually requires the US Navy to maintain 11 of these operational carriers to cover the globe. But next year, in 2026, the legendary USS Nimitz is scheduled to retire. It's 50 years old and running on fumes. The Kennedy was supposed to slide right into that slot. Because of this delay, the handover isn't happening. From 2026 to at least 2027, the US will drop to 10 carriers. That sounds like a small difference, but in the world of logistics, it's a crisis. It means other ships have to stay at sea longer, crews get burned out, and maintenance gets skipped. And this carrier gap is happening exactly when China is launching its own next-gen carriers. The Kennedy isn't just late for a party, it's missing the most critical window in modern naval history. So what exactly is taking so long? To understand failure, you have to understand the ambition. The USS John F. Kennedy isn't just an update to the old Nimitz class, it's a complete reset. Think of it as a floating city. It houses 4,660 sailors, roughly the population of a small town, plus its own hospital, post office, and police force. And Ford-class carriers have a 13,800-volt electrical grid. The old ships use steam pipes to move power around. The Kennedy uses a massive 13,800-volt electrical grid powered by 2 A1B nuclear reactors that generate 3 times the electricity of previous ships. We're talking 125 megawatts, which is enough to power a residential city. The idea was to build a platform that could host lasers and railguns in the future. But to make that work, the Navy had to integrate thousands of subsystems, from radar cooling to waste management, into one digital network. And that brings us to the core tension. They didn't just want a better ship, they wanted a technological leap. And sometimes, when you jump too far, you stumble. In the world of megaprojects, there's a golden rule: minimize your variables. If you're building a new car chassis, you usually put a proven engine inside. The Navy did the opposite. They decided to practice concurrency. Basically, they started welding the ship together while they were still inventing the technology that goes inside it. The Kennedy features 23 brand new technologies that didn't exist on previous carriers. They reinvented the radar. They reinvented the way the planes launch. They reinvented the way planes land. They even reinvented the elevators. The logic was that this would save time. Instead of waiting 10 years for the tech to mature, they'd build the ship and the tech in parallel. The ship itself became the test environment. The Kennedy's keel was laid in 2015. By 2019, the hull was complete enough for the ship to be launched into the James River, a massive milestone. At the christening ceremony, Caroline Kennedy smashed the bottle against the bow, just as she had done for the original carrier 52 years earlier. But even as champagne flowed, engineers knew the hardest work was still ahead. Installing 23 new technologies into a floating city wasn't welding steel. It was building a working nervous system. It was a bold bet, but as the Kennedy sits in the James River today, we are seeing the losing side of that wager. Let's look at what this ship is supposed to do. An aircraft carrier is basically a factory, but instead of making cars, its product is sorties, launching fighter jets. It works in a continuous loop. You bring a bomb up from the magazine, load the jet, launch it into the air, catch it when it comes back, refuel, and do it again. The Kennedy was designed to do this 33% faster than any other ship in history. It's all about rhythm. If one part of this loop jams, the whole factory shuts down, and right now, 2 critical parts of this factory keep jamming. This is where the billions of dollars collide with basic physics. The delays are about 2 specific choke points. First, the launch and recovery. For 50 years, we used steam to launch planes. It was crude, but it worked. On the Kennedy, they switched to EMALS, Electromagnetic Aircraft Launch System. It uses magnets like a roller coaster or a railgun to push planes. As for landing, they ditched the old hydraulic pistons for the Advanced Arresting Gear, AAG. It uses water twisters and electric motors to catch a 35-ton jet moving at 150 miles per hour. The problem was reliability. In testing, these systems have struggled to go long periods without a fault, and you can't have a computer glitch when a pilot is trying to land on a moving deck at night. The software integration for these magnets has been a nightmare, requiring thousands of test cycles to prove it's safe. Second, the elevators. This sounds mundane. It's just an elevator, right? Wrong. The advanced weapons elevators use magnets to move 24,000 pounds of missiles from the deep belly of the ship to the flight deck. They move faster than your office elevator. But on the lead ship of this class, the USS Ford, these elevators didn't work for years. The shafts warped slightly as the ship twisted in the ocean, and the magnets lost alignment. On the Kennedy, they're still fighting to get these 11 elevators certified. If the elevator breaks, the bombs stay in the basement. If the bombs stay in the basement, the jet can't fight. The entire loop stops. You might be wondering why not just take the ship now and fix the elevators later. The Navy actually tried that with the first ship, the USS Ford. They accepted delivery before all the systems were working. It was a disaster. The ship spent years in post-delivery fixing phases. It cost more money and took longer than if they had just finished it correctly the first time. Fixing a 100,000-ton warship while it's active is incredibly difficult. You have sailors living on board, systems alive, and you can't easily cut open walls. So for Kennedy, the Navy has drawn a line in the sand. No more buy now, fix later. They won't accept the keys until every single elevator goes up and down perfectly and every magnetic catapult fires without a glitch. That's why the date slid to 2027. They're forcing the builder to finish the job. When you zoom out, the story of the USS John F. Kennedy isn't really about a ship. It's a classic case study in the megaproject trap. We see this in nuclear power plants, massive airports, and high-speed rail. The ambition outruns the integration. The engineers were so focused on making individual systems, the magnets, the radars, the reactors, revolutionary, that they underestimated the chaos of making them work together. It's the difference between buying a reliable Toyota and trying to build a Formula One car from scratch in your garage. One gets you to work today, the other might set a world record eventually. But for now, it's just parts on the floor. For the sailors already assigned to the Kennedy, the delay means living in limbo. The crew was activated in 2019, 6 years ago. They've watched their ships sit at the pier while their peers on other carriers deploy, gain experience, and advance their careers. It's not just the Navy waiting for this ship. It's families planning around deployment schedules that keep changing. So, where does this leave us? March 2027 is the new target. If the Navy hits that date, the Kennedy will finally join the fleet. And to be fair, if they get these systems working, the ship will be a game changer. It will generate more sorties with fewer sailors and more power than any adversary can match. It was built to dominate for 50 years. But that dominance comes with a heavy price tag: absence. The question isn't whether the Kennedy will be a good ship. The question is whether betting on revolutionary technology and gambling 9 years of delays was worth leaving America's carrier fleet stretched thin at the moment China is surging forward. For now, the most advanced warship in human history sits quietly in Virginia, waiting for its software to load. If you want to understand more about how massive engineering projects can go wrong, make sure you subscribe to Megabuilds. Thank you for watching.